When we're dealing with rational expressions, it's very important to know what the factor pieces are. So we need to be able to factorize and see the multiplying pieces involved in a rational expression. And then a rational expression is a times and divide expression. Okay, times on top, divide on bottom. And if we can know all the multiplying pieces, we can deal with rational expressions much easier. So we need to be able to factor or break it into multiplying parts. So if I prime factorize 45, I can use a factor tree. So 45 can be expressed as 3 times 3 times 5 in this prime factored form. 75 we can factorize into 25 times 3. This becomes 5 times 5. Okay, so we know the number part is going to be 3 times 5 times 5. We have variable parts and we have two a's being multiplied, so we have 5 distinct factors. Here 55 can be written as 11 times 5. And then we can write this as 5 times 11 times an x times y times y. Okay, so again, in this case there are going to be again 5 factors involved here. So to write equivalent rational expressions, this is really a proportional equation. So when we have a fraction here, we can just say, okay, well, we have a times 2 multiplier, and we can say that that's going to end up being 6. Okay, so 4 over 3 is equal to 8 over 6. And that's easy enough to do, and we're using our multiplying strategies, in that we know that proportional equations or rational expressions are work proportionally. When we already have factors involved here, it makes it a little bit more complicated. So what we need to do is we need to think of matching factors, and the factors have to match not only the top but on the bottom. Okay, so on the top I'm going to rewrite this as 35 in terms of its factor pieces 5 times 7. Okay, and on up here it's going to be 21 is going to be 3 times 7. So I already have matching factors of 7 and 7. Okay, on the bottom here I have a factor of 3 and I have a factor of 5. Well, we can match the denominators. We can say that we're introducing a factor of 5 here. Okay, and I'd have put a factor of 3 here. Okay, so what ends up happening here is I have now a common denominator, but now I'm missing factors here. I need to, if I simplify this, I'm going to end up with 7 over 5, and this one ends up at 7 over 3. So in this case, I need an extra factor of 3. Here I need an extra factor of 5. Okay, and we can see that in the simplified form then, the factors now all match. So I need to get rid of that extra 5 on the numerator. I need to get rid of that extra 3 in the numerator here. Now I have 7 that matches, and the denominator 3 times 5, 5 times 3, those factors now match. Okay, so the idea is then we need to make all the factors match. If we have excess factors, we need to be able to cancel some out. So again, here we can write this as 7 over 3. Okay, and here we have 21. It's going to be 3 times 7. And I'm going to write 6 as 2 times 3. Okay, so we have an extra factor of 3 in the numerator here, but notice that we can simplify that with what's already there with part of the 6. Now we just have to make the rest of this match. Okay, so I need to introduce a factor of 2 that's missing on the denominator here. I'm missing a factor of 3 in the denominator here. So I end up with now 7 over 6, and those now match. Okay, so the answer to this would be 2, and the answer to this would be 3. Here we needed to introduce a factor of 5. Here we need to introduce a factor of 3. Oops, sorry, that's not correct. This is 5 times 5, because one of the 5's canceled, and here was 3 times 3, because one of the 3's canceled. So what must match if the rational expressions are to be the same? All the factors in the numerator, and this is important, the factors. This is really important to be able to analyze these rational expressions in terms of parts. All the factors in the numerator and denominator must match.